pollination machine, and who is my friend. Pollination is a process where by which pollen is transferred from the male representative organ of a flower to the female representative organ of a flower. Long time ago, it is nature that helps plant doing their pollination process, which, as we all know, by utilizing wind and animals, like bees as an example. However, this way seems inconvenient anymore for us to use. Let's say we would know where or when the pollination will happen. We also couldn't force which bees or plants that will take part. So, knowing the fact that there are actually many advancements in technology tools, such as Arduino motor stepper, which is what we are approaching now, we propose that we will substitute these bees by this machine pollination process.
We are considering that our solution is wiser based on some factors, of course. The first one is that we thought that this pollination machine is more efficient than the natural pollination one. Because in natural pollination, amount of pollen may be waste or lost due to some factors like wind, rain, or the movement of the animals. In contrast, machines, we can program them to apply the only right amount of pollen to each flower, so it can increase the efficiency of the pollination process. And the second one, of course, it is more precise. Machines can be designed to target specific plant species, ensuring that the right pollen will go to the right flower. So this is important, for example, in the crop production, where specific traits such as disease resistance or high yield may be desired in the process. And the last one, but not least, it is that the pollination machine is more consistent. In natural pollination, it can be influenced by a range of factors, external factors, such as the presence of predators or the availability of nectar and pollen. So whereas machines can provide a consistent amount and pollination surface regardless of what happened in external factors. And the mechanism will be explained by Jose.
So when we have a chassis, there are quite a few methods in which you can enable an object to move, specifically in the X and Y axis. For this demonstration, we have decided to use the rack and pinion method, which converts rotational motion into linear motion or vice versa. What we have here is a system of gears which is going to be motorized by our motor stepper, which is connected to the Arduino system. And so we can program that in which it will rotate. In this specific example, we have chosen it to rotate one rotation before it pauses for 3 seconds. If we were to implement it in our real situation, how this would work like is you can measure the distance between one plot of plants to the other and see how many seconds that takes for the pollen to get from one grid to the other grid. And so you can make pauses and measurements based on that. But that doesn't limit the possibility for us to also control the pollination system from our program. And we will continue to demonstrate how the rack and pinion system works. Right, so it's as simple as programming the pauses and the rotation on the Arduino IDE system. And see, after one rotation, it pauses for 3 seconds, in which the implementation for our real-world situation is our pollen, which is contained in this container. It has a nozzle in which the pollen can be excreted from. Okay. And yes, like we said, we think that this way of spreading pollen into an automated farming machine is more efficient compared to the natural way that pollen is distributed. And seeing the big picture, if you can implement this in a farm specifically for growing crops and or the others, like why not choose this over our natural way of distributing pollen? And that will close our presentation for today. Thank you.
Thank you.
Yeah, I think it's a very interesting prototype. I think it's quite an interesting premise too. So you're basically just making a CNC machine for pollination.
Oh, yeah.
So actually by doing this, having the rack and pinion gear, you actually kind of like knew how to make a 3D printer basically.
Yeah.
That's basically the same principle but moving in 3 different directions. So I think it's a very interesting project. I like the prototype. So yeah, well done.